150 feet of USS New Orleans vanished in a single explosion, the forward magazines detonated, and the cruiser lost roughly 1/4 of its length, yet the shattered ship remained afloat and began moving toward Tulagi. How did a cruiser missing its bow survive long enough to reach port? The answer begins with a battle the Americans expected to control on November 30, 1942. 5 American cruisers approached Guadalcanal after dark. 6 destroyers accompanied them through waters already crowded with sunken warships. Their mission was to intercept another Japanese supply run toward the island. Rear Admiral Raizo Tanaka commanded 8 Japanese destroyers approaching from the northwest. Most carried drums of food and ammunition for troops fighting on Guadalcanal. The American force held several advantages that should have been decisive. It had warning of the Japanese movement, superior gunpowder, and modern surface search radar. The leading destroyers detected targets before the Japanese formation could attack with gunfire. At 11:20 that night, American destroyers launched 20 torpedoes. A minute later, the cruisers opened fire across the darkness. USS New Orleans followed the flagship Minneapolis at a distance of about 1,000 yards. Her radar team initially mistook the Japanese formation for part of Guadalcanal's coastline. Then the shape separated from the land. The nearest targets were about 14,000 yards away. New Orleans opened fire using radar control against a Japanese destroyer. Her 8-inch guns delivered 4 rapid salvos. Observers believed the target had exploded across the American formation. Radar screens and shell splashes created an illusion of overwhelming success. Several crews reported Japanese ships breaking apart or disappearing. Those reports were badly mistaken. Only the destroyer Takanami had been struck with devastating effect. The remaining Japanese ships had already turned away from the American gunfire, but their most dangerous weapons were still moving through the water. Tanaka's destroyers had launched Type 93 oxygen torpedoes during their withdrawal. These weapons carried heavy warheads and could travel far beyond expected American torpedo ranges. The American cruisers did not see them approaching. At about 11:28, 2 torpedoes struck Minneapolis. The flagship's bow folded downward, forcing the ship to slow abruptly. New Orleans was directly behind her. Captain Clifford Roper ordered a hard turn to avoid colliding with the crippled flagship. That maneuver saved the ships from striking each other. It also carried New Orleans across the path of another torpedo. The weapon struck near the forward main battery. Its explosion ignited aviation gasoline and detonated the forward magazines. The blast destroyed everything ahead of the second 8-inch turret. The bow did not separate cleanly. It twisted toward the port side while the cruiser was still moving. Steel structure tore apart between the first and second turrets. The severed mass scraped along the hull before passing down the ship's side. Then it disappeared beneath the surface. The first turret, its guns, the anchor equipment, and approximately 150 feet of ship were gone. 183 sailors were killed. Steering and engine control from the pilot house failed immediately. Telephone connections to secondary control positions also went dead. The main deck was wrecked as far aft as frame 42. Floodwater entered compartments behind the missing bow. The remaining forward bulkhead now faced the sea directly. It had never been designed to serve as the front of the ship. Every movement drove water pressure against that single damaged barrier. If it collapsed, flooding could advance into the surviving hull. New Orleans would then follow her missing bow to the bottom. But the torpedo had produced one unexpected result. Despite the magazine explosion, it had not started a major sustained fire. Before the battle, the crew had removed excess paint and combustible material. Captain Roper later considered the lack of serious fire evidence that those precautions had worked. The ship had lost its bow, forward weapons, communications, and many of its crew. It had not lost electrical power everywhere. Its machinery aft remained capable of turning the propellers. Damage control teams now had a narrow opportunity. They could not replace the missing structure. They could only prevent the surviving structure from becoming the next failure. While the battle continued behind them, sailors entered flooded and shattered compartments. Their first task was not to make the cruiser seaworthy. It was to keep one exposed bulkhead standing for the next few minutes. That bulkhead was already bending under pressure, and every turn toward Tulagi forced the sea harder against it. The surviving bulkhead was not the only danger. New Orleans was still inside enemy-controlled waters, without normal steering or reliable bridge communications, if Japanese destroyers returned. The crippled cruiser could neither maneuver nor fight effectively. The crew first had to discover which parts of their ship still answered commands. Electrical power remained available in much of the surviving hull. The engine rooms and fire rooms aft of the explosion were still operating. Propulsion had survived because the torpedo struck far ahead of the machinery spaces. That separation became the first mechanism keeping New Orleans alive. The ship was catastrophically shortened, but its engines had not been drowned. Its propellers could still generate movement. Movement, however, was now dangerous without a bow. The remaining hull presented a broad, nearly vertical surface to the sea. Higher speed increased pressure against damaged plating and the exposed transverse bulkhead. Captain Roper reduced the cruiser to only a few knots. This was not simply a cautious choice. Speed had become a structural limit. The machinery could drive the ship faster than its wounded hull could safely endure. New Orleans initially swung toward the east after control failed in the pilot house. That direction carried her generally toward Tulagi, across the waters east of Guadalcanal. But the ship could not depend on its usual command network. Orders had to travel through surviving stations and improvised communication routes. Engine speed became a substitute for some lost steering control. By changing power between the shafts, the crew could influence the cruiser's heading. It was slow and imprecise. Every correction risked exposing the broken front to greater water pressure. Captain Roper considered approaching Tulagi's stern first. Moving backward would reduce the force of water against the exposed bulkhead. The idea made mechanical sense, but the damaged cruiser proved almost unmanageable astern. Its missing bow had changed the balance of the hull. The damaged port inboard propeller further complicated control. Roper abandoned the attempt and resumed the approach ahead. The ship would have to face the sea with its weakest surface. Damage control teams worked below while sailors above watched for another attack. They removed loose material that could shift and worsen the ship's balance. They controlled flooding behind the forward damage boundary. They inspected compartments where plates, pipes, and cables had been torn apart. The immediate micro-payoff was clear. Flooding did not race uncontrollably aft. The remaining watertight structure was damaged, but it continued dividing the sea from the machinery spaces. The bulkhead held. That did not mean it was safe. It meant the crew had gained time. Elsewhere, the battle's scale was becoming visible. Minneapolis had also lost much of her bow. Pensacola was burning after another torpedo strike. Northampton had taken 2 torpedoes and could not be saved. Her crew abandoned ship before she sank during the early morning. The Japanese had destroyed 1 cruiser and crippled 3 others. They achieved this after the Americans detected them first and opened fire first. New Orleans had survived the initial blow. But no secure harbor lay beside her. Tulagi was about 18 miles from the damaged American ships. The approach required navigation through darkness, reefs, and narrow water. New Orleans no longer had her anchors. They had disappeared with the bow. Even reaching harbor would not guarantee that the cruiser could stop or secure herself. The destroyer Maury was ordered to find the damaged ship. At about 2:35 in the morning, Maury located New Orleans. The destroyer then helped guide the cruiser toward Tulagi. Radar mattered again, but now it was serving a different purpose. The same technology that had located the Japanese force was guiding a wreck through dangerous water. New Orleans continued at roughly 5 knots. Each mile confirmed that her engines remained dependable. Each mile also prolonged the load against the forward bulkhead. Near daylight, the cruiser entered Tulagi harbor under her own power. She moored alongside Maury because she had no anchors left to use. The impossible first journey was complete. A ship missing 150 feet of bow had crossed open water and reached shelter. But Tulagi was not a repair yard capable of rebuilding a heavy cruiser. It was an exposed forward base within range of Japanese aircraft. New Orleans could not remain there indefinitely. Before she could escape, her crew needed to transform an open-ended hull into something that could survive the ocean. The materials waiting on shore were not naval steel. They were timber, cables, and coconut trees. Reaching Tulagi solved the first problem and exposed a larger one. New Orleans was afloat. But the harbor could not provide permanent repairs. The nearest suitable dry dock waited far to the south in Sydney. Before any voyage, the crew had to rebuild the ship's missing boundary. Tulagi was primarily a forward operating base for patrol boats. It lacked the industrial equipment of a major naval yard. There was no prefabricated steel bow waiting beside the damaged cruiser. Repair ship USS Vestal arrived to assist, bringing tools and experienced specialists. Members of the 27th Naval Construction Battalion also joined the work, but most of the labor still fell upon the cruiser's surviving crew. Their first challenge was structural. The explosion had distorted decks and bulkheads behind the missing bow. Some steel surfaces had bent under forces they were never designed to absorb. The sea had also entered spaces around the second main battery turret. A damaged door and ammunition transfer opening weakened the surviving watertight boundary. The crew could not simply seal one hole and declare the ship safe. They had to support an entire damaged section against repeated ocean pressure. Tulagi provided one material in abundance. Coconut trees grew close to the harbor. Workers cut their trunks and shaped the timber into heavy internal supports. These shores were fitted against weakened bulkheads and decks. The goal was to distribute pressure into stronger parts of the surviving hull. Wood could not replace armor or structural steel. But in compression, thick timber could hold a damaged plate against further movement. That distinction mattered. The coconut logs did not recreate the cruiser's original bow. They helped stabilize what remained and formed part of a crude protective structure forward. The second challenge was water resistance. Sailors cleared jagged wreckage and closed openings left by torn pipes and ventilation trunks. They strengthened the forward boundary around the damaged second turret spaces. Every gap represented another route for spray or flooding. Every loose plate could enlarge that route under wave impact. The third challenge was concealment. Japanese aircraft still operated within reach of Tulagi. A stationary heavy cruiser with its bow missing would be an unmistakable target. The crews spread camouflage nets and local vegetation across the ships. New Orleans became so covered that one observer compared her appearance to a botanical garden. The camouflage did not make the cruiser invulnerable. It reduced the chance that reconnaissance aircraft would identify her condition and location. No major Japanese air attack arrived during the repair period. That absence became another unplanned part of the survival mechanism. The crew now had days instead of hours. They used 11 of them. While repairs advanced, investigators could see how extraordinary the damage had been. The explosion had severed the hull around frame 35. The detached bow had then struck the port side while sliding aft. It tore additional openings farther along the hull. It also damaged an inboard propeller before sinking. The cruiser had therefore survived more than the initial torpedo detonation. Its own severed bow had become a second weapon. An armored bulkhead near frame 53 helped stop that secondary damage from spreading deeper. This changed the explanation again. New Orleans survived through several separate barriers, not one miraculous piece of steel. Machinery separation preserved propulsion. Watertight subdivision restricted flooding. Fire prevention denied the explosion more fuel. Internal shoring reinforced damaged structure. Camouflage bought time for the work to continue. On December 12th, the decision could no longer be delayed. The temporary structure had not been tested by open ocean. Weather, vibration, and sustained propulsion would impose loads impossible to reproduce inside Tulagi Harbor. Sydney lay roughly 12 days away at the speed the damaged cruiser could safely maintain. New Orleans departed the forward base under her own power. She carried no real bow, only strengthened boundaries and improvised protection. The crew watched the forward structure continuously. A new leak could become progressive flooding. A failed shore could transfer pressure into the next damaged frame. Heavy weather could force the ship to turn back if turning back remained possible. The repair had produced a micro-payoff. New Orleans could leave Tulagi, but the solution had only moved the test from a sheltered harbor into the South Pacific. Now the ocean would decide whether coconut timber and damaged steel could remain together for 12 days. The first days at sea revealed why the Tulagi repair was only a calculated gamble. New Orleans could move, but ordinary navigation had become an experiment. The crew sometimes had to place the cruiser's stern first into worsening seas. Moving backward reduced direct wave pressure against the improvised forward structure. It also placed the rudder and propellers at the leading end of the moving ship. A heavy cruiser was never intended to travel that way across an ocean. The stern offered little of the hydrodynamic shape normally provided by the bow. Steering corrections came slowly, and the ship resisted holding a stable course. When conditions permitted, New Orleans could proceed ahead with extreme caution when waves threatened the damaged front. Reversing offered protection at the cost of speed and control. The voyage therefore became a sequence of compromises. The crew was no longer asking whether the engines could turn the shafts. They were asking how much movement the forward structure could survive. Sailors maintained watches around the reinforced bulkheads. They checked the timber shores for crushing, slipping, or movement. They watched seams for new leakage. Pumps had to remain ready even when flooding appeared stable. A small increase in water could indicate that damaged plating was opening farther aft. The danger was progressive failure. One shifting support could transfer load onto another. One enlarged seam could flood a compartment and change the ship's trim. That change could push the improvised bow deeper. Increasing pressure and opening still more seams, the crew's task was to interrupt that chain before it began. This was the second major reversal in the story. The ship survived not because the temporary bow restored normal strength. It survived because the crew never treated the repair as normal. Speed, heading, pumping, and structural inspection became parts of one continuous control system. The sailors adjusted the ship to protect the repair. They did not expect the repair to protect the ship by itself. The distance to Australia was about 1,800 miles. New Orleans covered it during 12 days at sea. That schedule left little margin for serious mechanical failure. The cruiser could not enter a nearby American naval yard if the damaged propeller worsened. It could not safely ride out every storm like an intact warship, and it remained a recognizable military target. Yet the machinery spaces continued operating. The reinforced damage boundary continued holding. The improvised structure remained attached. On December 24th, New Orleans entered Sydney Harbor. Christmas Eve brought a sight few people in the city could have expected. A 10,000-ton American cruiser arrived with the forward quarter of its original hull missing. The Voyage had answered one question. Coconut timber and damaged steel could survive the passage from Tulagi. But Sydney's engineers immediately faced a different test. They had to determine what damage remained hidden beneath the waterline. New Orleans reached Cockatoo Island Dockyard, the major repair facility inside Sydney Harbor. The ship could not enter dry dock immediately. Wartime demands filled the yard with other damaged vessels and urgent work. Temporary preparations continued while the cruiser waited. On February 3, 1943, New Orleans finally entered dry dock. With the water removed, engineers could inspect the full path of destruction. The examination confirmed that the torpedo was only the first blow. The severed bow had scraped along the port side. It ripped plating near frame 53 and struck the port quarter farther aft. It also damaged the port inboard propeller. An armored bulkhead had prevented one tear from extending farther into the ship. The dry dock revealed another crucial fact. The surviving forward bulkheads had deflected under pressure, but had not completely failed. The timber installed at Tulagi had supported structures already bent by the explosion. The material was primitive. The load path it created was not. Australian workers now removed wreckage that could not survive another long passage. They replaced the damaged propeller and prepared a fabricated stub bow. This new structure was steel, shaped and welded for a specific purpose. It still was not a complete fighting bow. It would restore enough hydrodynamic form and structural protection for the Pacific crossing. The cruiser had reached a real shipyard. It was still thousands of miles from permanent repair, and the next voyage would be longer than the first. Sydney's new steel bow changed the cruiser's shape, but not its status. New Orleans could cross the Pacific. She could not yet return to battle. The structure fitted at Cockatoo Island was a blunt, temporary shell. It protected the forward bulkheads and gave water a smoother path around the hull. Australian workers also replaced the propeller damaged by the severed original bow. Those two changes transformed the ship's operating limits. The cruiser no longer needed to protect an open-ended hull with every course adjustment. Its speed could rise beyond the cautious pace maintained after Tassafaronga, but the temporary bow carried no first main battery turret. It lacked the complete armor, internal subdivision, and equipment of the original structure. The ship remained shortened and operationally incomplete. Its next destination was Puget Sound Navy Yard in Washington State. Only a major American yard could fabricate and install a permanent bow. The route crossed thousands of miles of the Pacific. This was not a movement between nearby repair bases. It was an ocean passage by a warship still carrying severe structural damage. New Orleans departed Sydney on March 7, 1943. The temporary bow met sustained waves for the first time. Engine vibration traveled through repaired and unrepaired sections of the hull. Every day tested welds installed for transportation rather than combat. Yet the difference from the Tulagi voyage was immediate. New Orleans averaged about 13½ knots during the long passage. That figure revealed what Sydney's work had restored. The engines had always retained useful power. Now the hull could accept more of it. The ship was no longer crawling simply because its machinery was weak. Its earlier low speed had protected a structural boundary that could not tolerate normal operation. This provided another micro payoff. The cruiser's propulsion system had not merely kept her alive near Guadalcanal. It had preserved enough capability to carry her across the Pacific once the hull was stabilized. Meanwhile, Puget Sound did not wait for the damaged ship to arrive. Using surviving plans and measurements, the yard began fabricating a replacement bow. By April 2nd, the new structure was in its final stages of assembly. The repair process therefore happened in parallel. One temporary solution moved New Orleans toward Washington. A permanent replacement took shape before the cruiser reached the yard. When New Orleans entered Puget Sound, the contrast was unmistakable. The original fine bow had become a short steel cap. Behind it remained the second 8-inch turret and a hull built mostly with pre-war riveting. Ahead waited a new welded structure produced under wartime conditions on April 8th. The cruiser entered dry dock. Workers removed the temporary bow and stripped away damaged material. The new section had to align with the surviving hull across decks, frames, armor, pipes, and cables. This was more than attaching a pointed shell. The permanent bow had to become part of the ship's load-bearing structure. It also had to restore fighting capability. The missing first turret represented 3 8-inch guns and their supporting machinery. Its magazines, ammunition routes, electrical circuits, ventilation, and fire control connections had disappeared at Tassafaronga. The replacement section required all those systems to function as one ship again. The yard also used the repair period for modernization. New air search and surface search radars were installed. Additional anti-aircraft weapons strengthened protection against air attack. The forward superstructure was altered as part of the broader overhaul. New Orleans would emerge with a different silhouette and better sensors. But those improvements created a difficult historical distinction. They helped the cruiser fight later. They did not explain why she survived the night she lost her bow. That survival had already been decided before any naval yard touched her. The decisive sequence occurred aboard the damaged ship and at Tulagi. Fire prevention limited combustion. Compartmentation checked flooding. Propulsion remained available. Improvised communications restored control. Timber shoring supported distorted steel. Camouflage provided time. A temporary bow then converted survival into mobility. By early August, the permanent work was complete. New Orleans was whole again. But photographs still revealed the repair. The forward welded structure met an older riveted hull. It was a visible boundary between the ship that had been built and the ship its crew had saved. Now the Navy had to answer one final operational question. Could that reconstructed cruiser absorb combat strain again, or had Tassafaronga ended her usefulness forever? The reconstructed bow faced its first combat test only 2 months after the overhaul ended. New Orleans returned to Pearl Harbor on August 31st for training by October. The cruiser was steaming toward Japanese-held Wake Island. The distance from Tassafaronga was less than 1 year. That short interval matters because permanent repair had not merely restored appearance. The Navy had returned a nearly severed warship to an active striking force. On October 5th and 6th, carrier aircraft attacked Wake. New Orleans joined other cruisers and destroyers in bombarding Japanese positions. Its 8-inch guns again produced the recoil forces carried through the hull. Those forces were a direct test of the reconstructed structure. Every main battery salvo transferred vibration and stress through decks and frames. The repaired cruiser could not be treated gently during combat. It had to maneuver with the formation, maintain speed, and respond to enemy aircraft. Japanese torpedo planes attacked the force. New Orleans helped repel them and completed the operation without significant damage. The immediate payoff was operational, not symbolic. The rebuilt ship could fire, turn, and keep station under combat conditions. Tassafaronga had not ended its usefulness. Wake also demonstrated how the ship's role had changed. Before the torpedo hit, New Orleans had fought in confused night surface actions. After rebuilding, it increasingly supported fast carriers and amphibious operations. Its improved radars and anti-aircraft weapons suited the Pacific War now developing. The cruiser moved from emergency survival into sustained service. In November, New Orleans supported operations around the Gilbert Islands. The campaign pushed American forces deeper into the Central Pacific. Warships had to protect carriers, bombard shore positions, and remain at sea for extended periods. A hidden structural weakness could no longer be tolerated. The replacement bow endured those demands in January 1944. New Orleans moved against the Marshall Islands. Beginning on January 29th, its guns struck targets around the atolls. The The cruiser fired on air installations and shipping as American forces captured Kwajalein. The ship that had once entered Tulagi at only a few knots now operated inside another advancing fleet. This was the third major reversal. Survival had initially meant keeping one bulkhead intact for minutes. At Tulagi, it meant making the hull last for days. During the voyage to Sydney, it meant managing risk across 1,800 miles. Now survival meant something broader. The ship had recovered enough strength to absorb months of operational stress. Yet the crew could never fully separate that performance from the missing men. 183 sailors had died when the forward magazines exploded. Many battle stations disappeared with them. The rebuilt spaces did not erase that loss. They placed new steel where their stations had been. This distinction prevents the story from becoming a simple celebration of machinery. New Orleans survived as a ship because people accepted immediate danger inside the remaining hull. Some entered spaces threatened by flooding. Others maintained propulsion, while normal control systems had failed. Damage control sailors reinforced boundaries that might collapse without warning. Their choices preserved the platform on which later repairs became possible. The Navy recognized several members of the crew for extraordinary conduct. 3 Navy crosses connected to the damage control struggle were awarded posthumously. That fact changes how the word survival must be understood. The cruiser returned. Many of the sailors who made that return possible did not. By February, New Orleans was assigned to operations against Truk. The Japanese base was considered one of the strongest positions in the Central Pacific. American carrier strikes required screens capable of responding to aircraft and surface threats. New Orleans joined that force with modernized sensors and heavier anti-aircraft protection. During the coming months, the repaired ship would face another direct collision with destruction. This time, the threat would not arrive invisibly beneath the water. It would come from the air, strike near the stern, and cover the ship with burning fuel. The rebuilt bow would not be the part under immediate pressure. The crew's damage control system would. The next threat reached New Orleans from a friendly aircraft, not an enemy torpedo. Before that accident, the cruiser had already faced a demanding surface action near Truk. On February 17, 1944, American carrier aircraft struck the Japanese base. New Orleans joined a surface group moving around the atoll to intercept escaping ships. The assignment placed the cruiser near its former companion Minneapolis. Both ships had lost major bow sections at Tassafaronga. Both had returned with reconstructed hulls. Their targets now included the Japanese light cruiser Katori and accompanying vessels attempting to escape Truk. New Orleans opened fire at long range. The engagement demanded repeated salvos. Course changes and sustained machinery output. American battleships, cruisers, and destroyers combined their fire against the Japanese group. Katori, the destroyer Maikaze, and smaller vessels were sunk. The result offered another measurable test of recovery. New Orleans was no longer merely screening ships that carried the main striking power. Its guns were again engaging enemy warships directly. The repaired hull carried those loads without structural failure, but the action also exposed a hard truth about survival stories. A ship can overcome one supposedly fatal wound and still remain vulnerable every day afterward. The repaired bow provided no immunity from another torpedo, bomb, collision, or internal fire. The crew's real protection was not confidence in the rebuild. It was the ability to respond without assuming the previous danger had passed forever. New Orleans continued supporting operations around New Guinea. Its duties included patrol and plane guarding for carriers. Plane guarding placed a surface ship where it could rescue aviators after failed launches or landings. It also required operating close enough for a damaged aircraft to become a collision hazard. On April 22nd, a disabled aircraft from the carrier Yorktown approached New Orleans. The pilot could not complete a safe recovery aboard the carrier. The aircraft came toward the cruiser and struck near its stern before falling into the water. It exploded on impact. Aviation fuel sprayed across part of New Orleans. One sailor was lost and another was badly injured. The incident was far smaller than the destruction at Tassafaronga. Its mechanism was still dangerous. Fuel spread across a warship could reach hot surfaces, electrical equipment, or ammunition. A localized accident could become a ship-wide fire within moments. That chain had been interrupted before the Battle of Tassafaronga. The crew had removed excess paint and other combustible material. After the bow explosion, the absence of a major sustained fire helped save the ship. Now fire discipline and rapid response mattered again. The aircraft accident did not remove New Orleans from the operation. The cruiser continued patrolling and guarding aircraft. It then joined another strike against Truk in Satawan. On April 30th, its guns bombarded targets there. This provided the micro-payoff promised by the rebuilt ship. The return was not one ceremonial combat mission followed by withdrawal. New Orleans remained in service through repeated operations. The deeper mechanism was institutional. Damage control could not depend on a few specialists waiting inside repair stations. Combat damage often destroyed communication routes and killed trained leaders immediately. Survival required knowledge distributed through the crew. Sailors needed to close boundaries, fight fires, isolate damaged systems, and improvise communications before receiving perfect instructions. At Tassafaronga, normal control failed at the moment it was most needed. The ship lived because useful action continued anyway. That lesson did not belong only to New Orleans. The Guadalcanal campaign had forced the United States Navy to confront repeated night battles. Fires, torpedo damage, and flooding. Ships arrived with lessons written into warped steel and casualty reports. Procedures improved because the failures were measurable. Paint could be removed. Flammable stores could be reduced. Repair equipment could be repositioned. Communication alternatives could be rehearsed. Watertight discipline could be enforced before the first hit. These practices did not make ships unsinkable. Northampton proved that on the same night New Orleans was hit. They increased the time available between damage and irreversible loss. Time was the real reserve system. Every intact bulkhead, working pump, alternate telephone, and trained sailor added more of it. New Orleans had converted that time into distance. First to Tulagi, then to Sydney, then across the Pacific, the cruiser was about to carry that accumulated survival into the largest naval campaign of its war. By June 1944, the repaired cruiser was firing beside invasion beaches in the Mariana Islands. New Orleans bombarded Saipan, then screened carriers preparing for a major Japanese response. The Battle of the Philippine Sea brought large-scale air attacks against the American fleet. For New Orleans, survival now depended on radar warning, fighter defense, and coordinated anti-aircraft fire. These were precisely the areas strengthened during the Puget Sound modernization. The new bow had restored the hull. The new sensors helped the ship understand threats before they arrived. That distinction shows how recovery changed the cruiser rather than merely returning it to its earlier condition. New Orleans continued bombardment and patrol duties around Saipan and Tinian into August. Its 8-inch guns supported forces ashore. Its lighter weapons protected the formation from aircraft. The ship repeatedly changed speed and position close to contested islands. None of this resembled the careful passage from Tulagi. The rebuilt cruiser now operated under the same demands as undamaged ships. On August 13th, New Orleans returned to Eniwetok for replenishment. 2 weeks later, it sailed for carrier raids against the Bonin Islands. The cruiser bombarded Iwo Jima on September 1st and 2nd. It then supported operations around the Palau Islands. The sequence matters more than any single bombardment. New Orleans remained at sea through successive campaigns without requiring protection for its reconstructed bow. The repair had become ordinary ship structure. By October, American forces were moving toward the Philippines. Japanese naval planners responded with a complex operation involving several separate forces. Their goal was to disrupt the Leyte landings and attack vulnerable transports. New Orleans guarded fast carriers as those carriers struck each approaching formation. On October 24th, aircraft attacked the Japanese Southern Force. They then struck the center force inside the Sibuyan Sea. The next day, the carriers turned north against Japan's remaining carrier force off Cape Engano. The Japanese carriers were serving partly as decoys. Their aircraft strength had already been severely reduced. Their purpose was to pull the American fast carriers away from Leyte. New Orleans moved north with the covering force. By late afternoon, carrier aircraft had crippled or sunk much of the Japanese northern force. Several damaged ships remained on the surface. A separate American group was ordered ahead to finish them. New Orleans joined the heavy cruiser Wichita, 2 light cruisers, and 9 destroyers. The group raced northward toward the retreating Japanese vessels. This produced another direct surface engagement. The American ships caught the damaged light carrier Chiyoda. Cruiser gunfire struck the carrier until it sank. The force then encountered the destroyer Hatsuzuki. Unlike Chiyoda, the destroyer fought aggressively. Hatsuzuki used gunfire and torpedoes while attempting to delay the American pursuit. The engagement continued after sunset. New Orleans and the other American ships maintained fire until the destroyer was overwhelmed. The immediate micro-payoff was unmistakable. A cruiser once crippled by Japanese torpedoes was again fighting a Japanese destroyer in darkness, but the comparison with Tassafaronga reveals the deeper change. At Tassafaronga, American commanders saw early radar contact and superior firepower as sufficient advantages. They underestimated the reach and danger of Japanese torpedoes. At Cape Engano, the surviving ships understood that gunfire did not eliminate torpedo risk. They maneuvered within a fleet shaped by 2 years of harsh lessons. Technology mattered, but knowledge of enemy capability mattered with it. New Orleans carried both kinds of reconstruction. Its forward hull had been rebuilt in steel. Its operating culture had been rebuilt through experience. Neither guaranteed survival. Together, they reduced the chance that the same assumptions would produce the same disaster. After Leyte Gulf, New Orleans continued guarding carriers during attacks across the Philippines. The war had moved thousands of miles from the waters where its original bow remained. Yet one unresolved question still followed the ship. Why had the explosion removed so much structure without destroying the entire cruiser? The wartime damage report would offer an answer more complicated than the early story of gasoline and magazines. The official damage analysis overturned the simplest explanation of the explosion. Early accounts blamed the forward powder magazines and aviation gasoline tanks. The physical evidence did not fully support either conclusion. Investigators began with the Torpedoes' likely point of impact. One sailor had seen bubbles approaching between the first and second turrets. Because New Orleans was turning right, the probable impact area lay between frames 24 and 28. Damage beneath the hull showed that the weapon struck well below the waterline. The report estimated a depth of roughly 12 to 16 feet that placed the explosion close to a small ammunition compartment beside the shell plating. Its location proved crucial. The cruiser's principal powder magazines sat behind longitudinal armor. Those protected magazines were dangerous, but they were not the only explosive spaces forward. Nearby compartments carried aircraft weapons and demolition material. One bomb and mine magazine held a demolition charge and 49 smaller bombs. Another compartment contained 5 aircraft depth bombs, weighing 325 pounds each. These stores sat closer to the outer hull than the principal magazines. Fragments from the torpedo explosion could reach them before armor stopped the debris. Investigators concluded that this was probably what happened. The torpedo detonated outside the port bow. Fragments penetrated the nearby compartment and initiated aircraft depth bombs. That detonation then set off other bombs and demolition material. The combined explosions produced damage far beyond the torpedo's blast alone. This explains why approximately 150 feet of the cruiser separated. It also explains why the damage pattern did not resemble a complete main magazine explosion. If the large powder magazines between the turrets had fully detonated, destruction should have extended even farther aft. The ship might not have remained in one piece. The aviation gasoline theory also weakened under examination. Investigators found no sustained gasoline fire matching a major tank rupture. Parts of the detached bow retained enough buoyancy to remain visible briefly after separation. That evidence suggested the gasoline storage had not exploded as initially believed. The absence of a large gasoline fire was therefore not merely successful firefighting. It indicated that gasoline probably was not a primary contributor to the blast. This is the story's most important evidentiary reversal. New Orleans did not survive the complete detonation of every dangerous space in its bow. It survived a devastating chain involving a torpedo and vulnerable aircraft ordnance. The distinction does not make the damage minor. It identifies the boundary between catastrophic loss and total destruction. The main powder magazines appear to have remained outside that chain. Armor and separation limited how far the detonation could propagate. The damage still severed the ship near frame 35, yet it stopped off destroying the machinery spaces and most of the remaining hull. That structural boundary preserved propulsion. Farther aft, additional armor-restricted damage caused by the detached bow scraping along the port side. The cruiser survived because several destructive processes stopped at different barriers. Blast propagation stopped before consuming the principal magazines. Flooding stopped behind surviving watertight boundaries. Secondary hull damage stopped near armored structure. Fire stopped before becoming a sustained conflagration. Loss of bridge control stopped before becoming complete loss of command. Each barrier was incomplete. Together they prevented one failure from becoming every failure. The report also exposed a design lesson. Bomb magazines located close to shell plating were more vulnerable to torpedo fragments. Their contents could magnify an external hit into a much larger internal explosion. The ship's survival, therefore, produced information capable of protecting later ships. Engineers could study not only what held, but what should never have been placed there. This is why the wreck had value beyond its return to service. A sunken ship can reveal damage through recovered evidence and survivor testimony. A surviving ship can enter dry dock. Investigators can inspect bent frames, fragment paths, deflected bulkheads, and intact compartments directly. New Orleans carried the complete damage pattern from Guadalcanal to Sydney and Puget Sound. Its survival preserved the evidence explaining that survival. By the end of the war, the cruiser had accumulated 17 battle stars, but the most consequential service it provided may have begun at frame 24 there. One torpedo exposed both the weakness of ammunition placement and the strength of layered containment. The crew did not know that technical explanation while steering toward Tulagi. They only knew that the ship had not finished sinking yet. Their decisions turned that narrow uncertainty into the time investigators later needed to understand why. New Orleans ended its war far from the place where survival had first seemed impossible. In April 1945, the cruiser arrived off Okinawa for direct gunfire support. For nearly 2 months, it fired against shore positions and exchanged fire with coastal batteries. The repaired ship remained operational through the final major campaign of the Pacific War. When hostilities ended, New Orleans was at Subic Bay in the Philippines. It later supported occupation duties, recovered liberated prisoners, and carried veterans home. The cruiser had converted a few minutes of damage control into almost 3 more years of service. That outcome answers the central question without requiring a miracle. No single device saved New Orleans. The torpedo failed to destroy the machinery spaces. Armor kept the main powder magazines outside the probable detonation chain. Watertight subdivision prevented flooding from advancing through the entire hull. Removed combustibles reduced the danger of a sustained fire. Surviving engines provided movement when remaining stationary meant exposure. Alternate control methods allowed the crew to guide a ship after bridge systems failed. Timber shores strengthened bent bulkheads. Camouflage protected the repair period. Sydney's stub bow converted a damaged survivor into an ocean-going vessel. Puget Sound's permanent reconstruction converted that vessel into a fighting cruiser again. Luck remained part of the story. 6 Japanese destroyers had carried supply drums instead of torpedo reloads. They could not return to finish the crippled American ships. No major air raid struck Tulagi while New Orleans lay exposed. The weather allowed the improvised repairs to survive the voyage south, but luck only created opportunities. The crew still had to recognize and use each one in February 1947. New Orleans left active service. The ship remained in reserve until it was sold for scrapping in 1959. Its reconstructed bow and surviving hull were eventually dismantled together. The original bow remained beneath Iron Bottom Sound. For more than 8 decades, its exact location was unknown. In July 2025, a remotely operated vehicle examined wreckage near Guadalcanal. The structure, paint, and anchor arrangement identified the missing bow of New Orleans. It rested about 675 meters below the surface. The discovery separated 2 endings that history had joined. On the seabed lay the section destroyed at Tassafaronga and the battle stations lost with it. The rest of the cruiser had reached Tulagi, crossed the Pacific, and returned to combat. That contrast is the clearest evidence of what saved the ship. New Orleans did not survive because its damage was less severe than it appeared. It survived because the destruction stopped before eliminating every useful system. Its crew then protected those surviving systems long enough for the next solution to become possible. First came minutes, then 18 miles, then 12 days, then an ocean. A ship can remain alive after losing its bow, but only if its crew turns every remaining boundary into time.